Question 7.4. The curve with equation y is equals to x plus 12 over x passes through the point A, which is 2, and B. Determine the equation of the line perpendicular to the tangent to the curve at A. So firstly, let's first break this down and understand that the curve with the equation y is equals to x plus 12 over x, that passes through the point which is A, which is 2, and B. So what we can do is we can work out what B is by subbing in this point into this equation. So once we do that, we have B is equals to 2 plus 12 over 2, where we get 2 plus 6, which is 8. So that allows us to complete this point, which is 2 and 8. And if we break this down, thereafter we completed that unknown, and they want us to do now is determine the equation of the line perpendicular to the tangent to the curve at A. So if we were to draw some sort of curve, and if this is some sort of curve, let's say that's the curve, and if this is our point A, what we need to do is we need to determine the equation of the line perpendicular to the tangent. So here, let me just see, that's our curve, whatever it is, it doesn't. Let's say that's our tangent. And let's just make sure that it's only touching at one point. And if that is our tangent, slightly closer, okay, there's our tangent. We need to determine the equation of the line perpendicular to the tangent. So this is the equation, and if it's perpendicular, that means that it is at a 90-degree angle to that tangent. So let's just label these values here, that this is our tangent and this is the line perpendicular to the tangent. So firstly, what we can do is we can determine the gradient of the tangent, because once we have the gradient of the tangent, then thereafter we are then able to work out the gradient of the line perpendicular to the tangent, since the gradients multiplied together will give us -1. So firstly, what we need to understand here is that, and let's just make this part shorter just so we don't confuse it, that it's at that point, it's perpendicular there, and if we bring back our A here. So firstly, what we need to understand, at that point A, the gradient of the curve and the gradient of the tangent would be exactly the same. So firstly, we need the gradient of the tangent. And how do we get that? We need to find the derivative of that curve function, so dy by dx, essentially. And firstly, let's first write down what y is, and remember, we need to make sure that our variables are in the numerator, so in order for us to actually work out the derivative. So once we have y into its correct form to find the derivative, we can find dy by dx. So this will be 1 minus 12 x to the power -2, and then if you take it to the bottom, it's 1 minus 12 over x squared. And thereafter we need to figure out the gradient. So at which specific point? At specific point A, and at A we know the coordinates is 2 and 8, and here we can sub in the actual value for x. So here we can sub in x value, which is 2, and that will give us the gradient. So once we have that gradient, so here m of the tangent is equals to 1 minus 12 over 2 squared, which is then -2. So ideally, maybe our diagram is incorrect representation. It should have been at the other side, since we have in a decreased function, or decrease a negative gradient nevertheless, so we can actually change this graph around. So if this is some curve of some sort, however matter it carries on, doesn't matter. You can see this is tangent. This is the line perpendicular somewhere, right? So this is tangent. This is more accurate. And then this is the line perpendicular. And then we can just label this as the curve. Right, and with the equation of y is equals to x plus, x plus 12 over x. Okay, so once we have the gradient of the tangent, therefore m of the tangent multiplied by m of the perpendicular line is equals to minus 1. So therefore m of the perpendicular line is equals to half. So now this allows us to have the gradient of that perpendicular line. And once we have that, we have the gradient. The only other thing we need to have is the actual another point, and then thereafter we are able to get our equation of our line. So thereafter we have the gradient. Let's go sub it into this equation. Y minus y1 is equals to m into x minus x1. And thereafter we can sub in our point which we have at that specific point, which we have here again, which is 2 and 8, because it's perpendicular at that point. Just put that there. And thereafter it is 2 and 8. So if we sub in all these specific values, y minus 8 is equals to half into x, which is 2, minus x1, x minus 2. And thereafter we get the gradient of the perpendicular line, which is half x plus 7.